G'day there, you're watching the Aussie BIM Guru, and today we're going through lesson 7 of my Learn Dynamo series. So in the recent tutorials we've looked at working with Revit data, list management and data types, but today we're looking at working with Excel. So why is Excel, I guess, is a quick question, and it's the ease of formatting data. Excel is a very fast program at changing values versus Revit and also Dynamo, which are really built more for coding and BIM respectively. So Dynamo is really good at pushing and pulling Excel data, which we can then process in Dynamo itself. So today's tutorial will show you how to do that. And the two nodes that we'll be using predominantly are Export Excel and Import Excel, which you can see below. So we'll mainly show you how to export room data out to Excel, and then how to import and update room data from Excel. So we'll go straight to Dynamo and show you how that works. So basically we're working in the default Autodesk model. We have updated the room names to be all caps from our last tutorial on data, but otherwise it's consistent with the standard model, so you can follow along if you need. I set up a room schedule that just contains a few fields just for reference. So it has name, number, unbound height, department, base finish, ceiling finish, wall finish, and floor finish. And we're going to export all these fields out into Dynamo itself. There are other tools out there that can do this, but this is obviously a free tool, and you could build a tool that works for your company's data management standards versus having to use a plugin where you need to customize it. So we're going to start in Dynamo by just getting all rooms using category by name, which we showed in the last tutorial, and then getting all rooms. So you'll see once we run this, you'll get all 14 rooms in the model. And from there, we're going to want to get the element ID, because this is the thing we're going to use in order to handle the data back and forth so that we can identify the element. We're also going to get the parameter value by name. So we're going to get a few parameters. So we're going to extract basically a function. In our code block tutorial, we ran through how this works. Just to keep things simple, we might actually just make a list of strings instead. So what I'll do, I'll just copy this as a code block. And this is basically just a list of elements in square brackets. So when I feed this out, and if I run this, you'll get just a list of the parameters that we're getting. So we'll feed that in. So if I run this, because of the lacing of each parameter, it's not going to quite get what we want. It's only going to work across the first list. And even if we go to longest, I believe it still won't give us what we want, because it's going to our longest possible list. So what we really need here is we need a list map in order for this to work. So we're going to disconnect this here. And you'll remember in our list management series, a list map applies a function across a level of a list. So we're going to do list map. And basically what this will do, this will find the parameters of each element within this list. So we're going to feed in, this is our list and this is our function. And this element will feed in here at the list level, and we'll get the parameters as such. So now if I run this, you'll see we get the parameters for each list. But there's an issue in that we have empty data because we don't have anything in these cells yet. So we want to replace that with some text that will go into Excel, because otherwise Excel won't know how to write the data. So we'll just pull this back. Okay, so we're going to have to use the if node in order to get around this, which is in the Zebra package, which is logic if, because the standard one doesn't work. So our test is basically going to be, are these equal to nothing? So will these parameters equal, and we'll just get a code block here and just do double apostrophe to imply an empty string. The cell isn't technically empty. It's not an empty list. There's just nothing in it in terms of a text string. So that's our test. So if we run that, we should get a list of booleans that corresponds to whether it's empty or not. And that is going to be our test. But we want to work at level 1 of our list. So we're working at this level here. So we're going to activate levels and work at level 1. And if it's true, if it is actually empty, we're going to want to replace that with something. So let's replace that with just say $. But if false, we're going to want our data. So what we'll do is we'll just move these down out of the way, and we'll carry this data across. But likewise, we're going to want to work at level 1 again. We don't want to return sublists in this case. So those will both work at level 1. So now if I run this, we should get a fixed list. So you can see now all those empty cells do contain something, but we have an issue now that our list has become flattened. So we need to chop our list back into the right number of elements. So we're going to take a count, and we're going to count the number of lists we have. We could count a few different areas of the script, but probably the most logical one to count is just how many elements we have. And we're going to apply a list chop to the list to break it back into the right count. And we can take all these elements and just lower them out of the way, because our script is getting a little bit busy now. Okay, so we're going to chop this list by that length. And this should now break it back into respective lists of parameters. So now you can see we have 14 parameters, but actually it's not quite right at the moment. You can see that we have X amount of parameters, so we've counted the wrong thing. So what we really want to count is how many parameters we're actually playing with. So we're going to count this list here, in fact. And that should break it properly. There you go. And now we've got our data reformatted back in. So you can see that we have to do a little bit of data formatting before we get data out to Excel. But essentially this is our data. The only thing that we're going to want in addition to that is we need the element ID at the front of each of these lists. So we're going to add that. There's a few ways we can do it, but what we might do is just transpose our data. And what that will do is that will reverse the columns and the rows of the list. So essentially the first one is all the names, all the numbers, and each respective parameter from there. And we can just add item to front of that list. And we will just add our list of element IDs. And then you'll see we have our element IDs, and then we have our name, then our number. And from here we could also retranspose our list back into order. And what that should do is give us that, but now with the ID on the front of each element. There are some other ways to do that with a few less steps, but they do rely on some more abstract functions that are in typically custom packages in order to achieve that. You could do a list map with an add item to front, but it's a little bit more complicated. So what we're going to do then is we need to basically create our header row in Excel, or for Excel I should say. So at the moment we basically just have our columns of data. These are our rows of data. So we need our top row or our header row. So we're going to build our top row using list. Actually, we can probably do another add item to front. And what we're going to want to do is we're going to want to take all our parameter names from back here as our lists, and we're just going to add a string to the front called ID. And that should give us a list of strings. However, that looks like that's our added to end, so we want to add item to front instead. And this will be our header row. There you go. And then finally, we can add that to the front of our list. So add this to the front of that. So essentially what we've built is columns of data now, or rows of data that could be transposed into columns. So this is essentially our data fully processed. So what we need now is our export to Excel. So we need a few things here. We need a file path. So we're going to search for file path, and we need to browse to a file. In this case, I've set up a demo, and I've set up just a file called sample. And sample is currently empty. So I'll close sample, and we'll feed that in there. So we need to say the sheet name that sample is going to be sourcing, and we'll use a code block for this. So we'll just say sheet 1, which is the default sheet name in Excel. And our start row and column will be 1 and 1. And our data will be what we're feeding in from the add item to front. And we do want to overwrite the data, so that will be true. So we can connect it this way. I believe default is, actually, so 0 for row 1 and column 1. We will overwrite, and this is our data. Okay, and we'll just do a watch to see if the data is successfully transposed. Okay, and we'll save our script. So now all we should need to do is run our script, and it should update. So we'll go run, and you'll see there it is. Our data's actually come out to Excel. We'll just make these a little bit wider so you can see them. But there you go, you can see that just the power of how quickly that happens. You can see we have our IDs, our names, numbers, unbound height, department, base, finish, etc., etc. And all our dollar signs are empty at the moment. And what you can do with these is just copy one, Control F, find and replace with nothing. And essentially that is your table data structure. What we're going to do is just save this, just call it to send back. And we're going to add some data to this that we want to send back into the model. So you could technically add data that you want to overwrite, as long as you don't change these IDs, because this is how we're going to find the rooms to send back. Okay, so let's just say unbound height, we want them all to be 2.7 meters. Let's say, actually I believe the unbound height needs to be limit offset. I've made a mistake there, but this is how easy it is to change. So we just come back to here, limit offset. Might be height limit offset. So we're just going to quickly double check the parameter that we need. So you recall in our last tutorial, we used a node called parameters, just to see what parameters are available from an element. And this is just a way to get the name of the parameters you might want as well. So we're looking for limit offset is what we're looking for. So I think we have the right name. There we go. Now we can unfreeze that. And it should be as simple as just rerunning the script. There we go. And we'll see that now we have the limit offset instead. It looks like the limits offset hasn't come across. So I'll just double check in the model which parameter we should be getting for that unbounded height. Because we want to get the parameter that essentially is the false ceiling height, limit offset. So limit offset should be the correct parameter. So we'll just double check if that's coming through. Limit offset. I might just reopen the script just to be sure that we haven't got any data still hanging around that we're writing. Sometimes when you write Excel data, it can hold on to certain parameters. No, it's still empty. So we're just going to cross-check that our data is coming across. No, so limit offset seems to be empty. This is always a good way to sort of troubleshoot the data that you're trying to get out of the model as well, just to be sure that you're getting the right things. And then we can just freeze that again, check our parameters again. It appears that limit offset is a valid parameter, but up. So there we go. Letter case is really important. So I've used the small O there. It needs to be a big O. And we'll just unfreeze that. Now it should work. So it's very important to read the parameters carefully. And there you go. Now we have a limit offsets that we need. You'll notice that every time you export to Excel, everything gets unformatted, which can be quite frustrating. There is a custom package I'll run through that shows how to fix that. Let's say we just want to make our numbering a little bit more interesting. So we'll just say that we want it to be 2.06, 2.07, 2.04, 2.03. This isn't a very intelligent way to populate the data in Excel, but this is the way I'm doing it. You could apply a rule, especially if this was a large model with lots of data. There would be more intelligent ways of doing that. Okay, so let's just say all our limit offsets are going to be 2700. And let's just say for certain departments, we'll make particular departments. So we'll just say our bedrooms and our master baths belong here. Bathrooms are amenities, bedroom. Let's just say we want living for all the areas. Actually, we'll just go KLD for kitchen, live and dining. Amenities. Mechanical, interesting. There's a plant in this building by the looks of it. Okay, so we'll just say base finish. We'll just put in some really basic things. Let's just say we want to make floor tile. So this could be a really handy technique when you're trying to batch populate finishes, because we can obviously use more Dynamo scripts from here in order to actually add some scripts that can build floors based on the data of a room, which we may actually do in a future tutorial. Okay, ceiling finish. We're just going to go plasterboard for all of them just to save time. And plasterboard for all these. The codes I'm using are obviously just nominal, so don't take them too seriously. For base finish, actually, we'll just do concrete for all of them, and then floor finish is the applied finish. Okay. So this is our data that we want to send back into the model. We'll just overwrite that. Okay, so that's our first script. What we're going to do is just basically rehaul this script into an importing script instead. So that was read, and now we're going to make write. So I think we actually called that write by accident. I might just call that write 2. So now we're going to modify the script to work the other way around. So essentially, really, we need to work the opposite way. So we're just going to freeze this down as our reference. But what we really need is import Excel instead. And we're going to start extracting some data from Excel. So you'll notice here for import Excel, it doesn't actually say file path, it says file. So what you're going to need is file from file path. File from path. And we'll feed in the file from this path. That's so it can process the data to send back. Okay. So we'll take that, and our sheet name again will be sheet 1. We do want to read as strings, and we don't want to show Excel. So do you want Excel to open while you do this? And we don't. Okay, so we're just going to run that straight away and see what we get. So now you see this is our data, but instead it's in Excel format. So these are basically our parameters that we want to get. So what we're going to do first is we're going to remove the first item of everything. So we're going to transpose this list, and we're going to take the first item, because we want to basically process our IDs in order to match our rooms to the data that we need to set the parameters for. Okay. So this should be ID, and then our element IDs from here. So we're going to drop first item, and we'll drop the first item of the list as well, because we don't want to process ID. Okay. So I don't know if there's a way to do select by ID, but what we can do instead is we'll do a match. Yeah, I don't, no, I don't believe it's going to work. So we're going to have to get all rooms and use it in a different way. So we're going to just unfreeze that. Okay, so we're going to get all the rooms in the model, and we're going to get the element ID again. But let's say there's more rooms in the model than there was before, potentially. So what we want to do is find a match for each of these. So we're going to get a list of all the IDs out of Excel, and a list of all the IDs out of Revit. And at the moment, they fully match. But at the moment, we won't shuffle anything, but we need to make sure that we get the rooms that correlate to this. So we're going to get index of, and we're going to find the index of this in that. And that will basically return the respective index. I believe we may need to convert these to strings as well. There we go. At the moment, our indexes match because we're dealing with the same set of rooms. If you had more rooms, it would obviously, you'd find that some of these rooms would get processed out. So we then do get item at index. And from this list of rooms, we're going to get those respective element ID indexes. There you are. And now we have those rooms that we want to add the parameters to. If the rooms are in a different order, at that point, we would be able to actually get, I guess, a valid input of all those rooms. So if we did a shuffle before we got an element ID, we'd still be able to find the rooms in the right order. So if we just do this shuffle, and then we take that value. There you go. We still end up with the right order of elements, despite the fact that they're not in the same order here. So you can sort of see how that process works. So we're just going to take this piece of the list, and we're just going to move this out of the way. And what we really care about is this node here. So get rooms. But what we're left with here is a list. So we're going to want to drop the first item again, because we don't care about the IDs now. Okay, and that will leave us with the rest of our data. So what we're basically left with here really is the parameter name and then the parameters. So what we want to do is transpose this list. And we want to take the first item out, because basically the first item is our parameter names. And from there, everything else is our parameter values. So we're going to drop the first item again. What we're also going to do is get the first item at index. Okay, get item at index 0. I'm being a little bit messy here compared to how I'd usually code, as you can probably see. But really what we want to break that down to is our parameter names and what needs to be set to them as a result. And that is in the order of the element IDs. Okay. So from there, really what we need to do is set our parameters. So we're going to use our set parameter by name. Okay. Alright, so we've got our data to a point where we have a set parameter by name set up. You'll see we've got 14 rooms, and we've got a list of 14 parameters with seven fields for each. So basically these are the parameter sets for each room. But then we only have seven parameters. So we need to figure out, 8 parameters. So we need to figure out how we're actually going to set these parameters. There's a few ways to do it, but I find the easiest way is to take advantage of list lacing and repeating items. So we're going to do a list of repeated item. And we're going to repeat the list of parameters. And the number we're going to use is the number of rooms that we have. So we're going to take a set of those for each. So we'll do a count for how many rooms we have. That'll be our amount. So at this point, if we ran that, we'd end up with a set of parameters for each room that we're going to populate. And this will enable these parameters to come across via those parameters per set per room, if that makes sense. But what we need to do first as well is we need to clean up the data here, because currently we don't have a number, we have a string. So you might have recalled in one of my earlier tutorials where I said that data type is really critical. So we actually need to convert all the items at index 2 here. So we're going to basically do a get item index, and we're going to get the item at index 2 in every single one of those lists. But we're going to work at level 2, so we're going to take it from the sublist. So we're going to work at level 2, and that will basically give us those numbers. And we're going to have to do a replace item at index. And also a string to number in order to convert those to data that Revit will accept. Okay, so this will now be a set of numbers, which we can feed in as our item. And our index will also be 2, and we feed through to this list. So we need to work at level 2 for this list to replace the number at that level. However, here we're going to work at level 1. So we need to activate levels at 1. Okay, so if I rerun that, you'll see that it looks the same, but it's technically not. So for example, the one way you can test that is by doing a plus, and we can say plus 1000s. And you'll expect some errors, because obviously not all those things are numbers, but you can see at least that this one is working. Obviously it's concatenating the text on the other ones, but this one is growing. However, what we do is if we say our original list instead, you'll see that we're concatenating on there. So that's how you can tell that we've replaced this to a number. And now we should just be able to feed through this list as our values, and this will be our parameter names. And this sort of should be sufficient to populate the parameters in the model. So if we just run that and go back to our model, you can see that all that data has been updated in our rooms. So obviously we have a very powerful workflow here that we can take advantage of. And we've just done this for rooms. You can do this for all sorts of elements in Revit. You can do it for multi-category schedules. You can even get Revit schedules and export those as well and re-import based on the Revit schedules themselves. But there's a few workarounds you'll have to do in order to isolate the element ID, which can't always be put in the schedule itself. So that's pretty much the demonstration of how you can use Excel in Dynamo. There's also another tool called Bumblebee, which is a custom package, which is a little bit more smooth at managing data to Excel, and it gives you a lot more options. So you may have noticed when I was writing Excel data that it was formatting the column widths to be the default every time, and it was also resetting the data in the tables. Whereas Bumblebee can allow a few extra things, such as maintaining files that aren't being rewritten. So it will overwrite certain portions of data, but not replace the rest of the tab. You can also maintain formatting and also add formatting as well. So Bumblebee looks at it a little bit like this. So it has a different write Excel, but then it also builds up a set of Bumblebee data. So this is basically a bunch of commands that are being fed into the write Excel command for Bumblebee. But you could do a list create and have multiple actions happening at the same time for a single write Excel to a file. And it's a bit better at telling you if it worked or not. It will tell you whether it was successful. So it's worth looking into that package as well if you're interested. And if you need any help, it's always good to go to the primer or the forums, as I've been saying in each session. And the next lesson we'll be looking at family types and instances, so how to manage type data and update it using Dynamo, and also interrogate family instances and place families as well. So hopefully I'll see you on the next session. If you enjoy what you're seeing, feel free to subscribe and leave any comments down below if you've got any questions or any feedback, and I'll see you in the next lesson. Take care. Bye.